Hello, algebra students, and welcome to our second lesson here on linear functions. So for today's lesson, or 5.2, we are talking about intercepts. I'm already surprised that we're getting into intercepts right away. So what we're going to be talking about is y-intercepts and x-intercepts. Basically, as we get into this, the basic definition is where does this function or this linear function cross the y-axis, and where does it cross the x-axis? The x-intercept, where does it cross the x? Y-intercept, where does it cross the y-axis? So here is our lesson objective. I can find x and y intercepts and interpret their meaning in real-world situations. I can use x and y intercepts to graph lines. So we're going to talk about a second way to graph lines today. Woohoo! So after today, you should know 2 different ways to graph a line. And then we'll use them how to interpret these situations. So using intercepts. Who uses this? Drivers can use intercepts to determine the time a safe ascent will take. So how long it's going to take them from going to point A to point B. A driver explored the ocean floor 120 feet below the surface and then ascends at a rate of 30 feet per minute. The graph shows the driver's elevation between sea level during the ascent. The y-intercept is the y-coordinate of the point where the graph intersects the y-axis. The x-coordinate of this point is always 0. So if you notice here, here's your y-intercept. This is where it crosses my y-axis. The x is always going to be 0 for your y-intercept, and then it's going to be the value of where it crosses on the y-axis. The x-intercept is the x-coordinate of the point where the graph intersects the x-axis, and the y-coordinate is always a 0. So in this case, they have 4, 0. So they talk about the y-intercept. They say the y-intercept is negative 120. It represents the diver's elevation at the start of the ascent when time is 0. So really what they mean to interpret these values is being able to understand what the 0 means within the relationship and what does this negative 120 mean. Well, it means that at a time of 0, because that's what your x is measuring, you are at an elevation of negative 120. Then your x-axis says that the x-intercept is 4. It represents the time when the diver reaches the surface when the depth is 0. So the time is now 4 minutes. His depth or his elevation is 0, and that's what it means to interpret those. So being able to know what your x and your y mean within your relationship or your problem is going to really help you determine what do those x and y values really mean, or intercepts. So we are going to go ahead and find the x and y intercept for A and for B. Now I took one picture from the textbook just to make it easier, but there is 2 problems here, A and B. So A is already a graph, which is awesome. I think the easiest way to find your x-intercepts is by taking that graph. And so, or x and y intercepts. So if I notice, here's my x-axis, so where does it cross the x-axis, which is right here. So I'd say my x-intercept is at the point, looks to be negative 4, 0. Sometimes they'll also say that it's just negative 4. I will accept either version, so the actual coordinate point of negative 4, 0, or that you just put negative 4, because remember the x-intercept means that y is going to be 0. So my y-intercept, so where does it cross the y-axis, which is right here, and if I'm following the pattern, it looks like this is negative 1, negative 2, negative 3, which would be the point 0, negative 3. Or you could just say that the y-intercept is negative 3. So it crosses the y-axis at negative 3. Now for B, it's not as simple. They give it to me in that standard form. So something's being times by x we're adding or subtracting, something's being times by y, and then we've got a value. When I've got something in standard form, the best way to change this is to get it into a y equals form, okay? So I'm going to rearrange this equation so that it goes y equals, and then I can create a table or a graph, and then I could graph it to determine what those x and those y values are. So I'm going to have 3x minus 2y equals 12. We want to get y by itself, and so I'm going to worry about this 3x first. The 3x is a positive 3x, so to get rid of it, I need to subtract it. Whatever I do to one side, I do to the other. These cancel out. I'm still left with this minus 2x, or negative, 2y. And then these are not like terms, so I have to keep them separate. So 12 minus 3x. And then I need to get rid of this negative 2, so on each side I'm going to divide by a negative 2. I'm going to rewrite it up over here. So these cancel. I'm left with y equals, and 12 minus, or divide by negative 2 is negative 6. And then a negative 3 divided by negative 2. And I can keep this as a fraction. It would make it a positive, so I'm going to add it as a plus 3 halves. Halves x. So we're going to still use our table to help us make a graph for this. I'm going to create some, maybe negative 1, 0, and a positive 1. Maybe 2s would be easier. Let's do 2 and a positive 2. So negative 2 times 3 halves would be negative 6 halves, or negative 3. Negative 6 plus a negative 3 would be negative 9. A 0, well, 3 halves times 0 is 0, plus a negative 6 would be negative 6. 2, well, 3 halves times 2 is a positive 3, so negative 6 plus a positive 3 would be negative 3. So if I started graphing this, we go negative 2, negative 9, and I'm just going to pretend that each dot is one value. So over 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a lot. All right, 1, 2, 6, and then I would have 2, negative 3, 1, 2, 3. So if I were to connect these, as best I can, if I use a straight line, let's actually add another point to my table. What if I did 4 here? 3 halves times 4 would give me 12 halves, which is the same as 6, and negative 6 plus a positive 6 is 0. So at 4, I would have 0. So I connected these in my graph, and I notice where they cross both the x and the y, or the y and the x. My x-intercept, let's move this over here. My x-intercept is right here at 4. And my y, and I'm just going to abbreviate it, my y-intercept would be at negative 6. Again, you can keep it as that coordinate point, or I'm okay with just that value of where it crosses. So those would be my intercepts, because I notice when I graph it, they cross at the y here and cross at the x here. So that one takes a little bit more graphing ability to go through. Okay, we got a couple more examples. So this one, I think we might skip this one. Let's go to this one, and if we've got more time for 2, we can do 2. I think this one's a little bit more of a better example, though. So this one says, use intercepts to graph the line described by each equation. So we get to find our intercepts again based on these equations, and we are going to graph it then. But there is an easier way than what we did in example 1. Example 1, I rearranged the equation to make it y equals. I set up a table, then I graphed it to figure it out. On this side, there's actually an easier way to do it. To find my x and my y intercepts, remember that at one point they told us that that means that if I'm finding the y-intercept, that means that the x-coordinate point is always going to be 0. And if I'm finding the x-intercept, the y is always going to be 0. So we can use that to our advantage to solve these equations by plugging either in 0 for x or 0 in for y. So in this case, to find my y-intercept, I'm going to plug in x equals 0. So into my equation, I'm going to put 2 times 0 minus 4y equals 8. Well, 2 times 0 is 0, so I'm just left with minus 4y equals 8. If I divide this out, negative 4, my y-intercept then is 8 divided by negative 4, which is negative 2. So then when I look at my y-axis, remember my y-axis is the one that's vertical, I just need to plot a point at negative 2 or 0, negative 2. Because that means x is always going to be 0. If I want to find the x-intercept then, that means y is going to be 0. So when you're finding those intercepts, you're going to think the opposite one needs to be 0. So instead of putting in 0 for x, this time I'm going to put a 0 in for y. So 2x minus 4 times 0 equals 8. Well, this makes it 0, so I'm left with 2x equals 8. If I divide out the 2, x then equals 4. So on my x line, I'm going to need a point at 4 or a 4, 0. So 1, 2, 3, 4. And now you have 2 dots. 2 dots are all you need to make a line. And so as best as you can, it's harder for me to draw it straight. But here would be my graph then, my linear function. So now this is another way to graph. You can use a table or you can find your x and y intercepts to graph. All right, so again, let's start with we started with y-intercept. Let's start with y-intercept for this one too. Y-intercept, which means I'm going to plug in x equals 0. So I've got 2/3 y equals 4 minus 1/2 times 0. Well, this makes it 0. Minusing a 0 is not going to do anything. So I'm left with 2/3 y equals 4. We could divide by 2/3, but the easiest way is actually to flip this to 3/2, because multiplying by the reciprocal is going to cancel it out, because 3 times 3 cancels, 2 times 2, so I'm left with y. And then I can multiply across, because 4 is the same as 4 out of 1. So 4 times 3 is 12, 1 times 2 is 2, well, 12/2 is the same as 6. So my y-intercept would be 0, 6. Or on the y-axis line, I should put a dot at 6. So 1, 2, 3, 4, 5, 6. All right, we need to find our y then, or x then. So x-intercept, we'll get this done pretty quick. Y equals 0, 2/3 times 0 equals 4 minus 1/2. So then we have 0 equals 4 minus 1/2 x. We're going to have to move this 4 over, so we're going to have to subtract it. Negative 4 equals negative 1/2 x. If I undo this negative 1/2 or multiply by 2, 1, negative 2, 1, I'm going to end up with x equals 8, or the point 8, 0, 1, 2. All right, connect them through, and here is another way to graph. So it's okay that we skipped example 2. I think this was more important. We'll continue practicing this graphing skill in class. See you then.